Welcome back to Takeout. Welcome back to the Conversation Corner. From Apollo 11 to Artemis II, NASA space missions have provided numerous images of a beautiful, seemingly smooth, perfectly round Earth. But now, new renderings from NASA reveal something quite different. Viral measurements of the planet's gravitational field show our home looks more like a lumpy potato than a blue marble. Senior science editor at Wired, Brian Kahn, joins me now. Brian, I'm so glad you're here. Is what we just saw more realistic and therefore truer to what we should understand about the planet? And if so, why is that important?
I would say it's realistic in the sense that it is measuring something important. It's not exactly how the planet looks. I'd say this looks like a lumpy potato that we just saw. Our planet's probably maybe, let's say, a little bit more like an orange. So there are some lumps and bumps, but it is on the whole still a pretty smooth space. But what this does show is something really important. It shows the state of gravitational pull across the planet. So, something that has a lot of mass, like a mountain, will have more gravitational pull than a valley. And so that's what this is showing essentially is like the different levels of gravity in different places. And it's showing what it would look like if those were the only forces, along with rotation, basically stretching the world's oceans out. So luckily, we're not living on this lumpy Earth. We're living on a nice round planet. But in an exaggerated form, this is what the forces of gravity look like.
And how were these renderings made, Brian?
So they're made using these really, really powerful satellites. NASA has a couple really cool satellites that are able to measure these minute differences in gravity. So you and I, we're not going to feel it. If we're standing on the top of Mount Everest, we might feel lightheaded because the air is thin, but the gravity doesn't feel that difference to us there versus down at sea level. But these NASA satellites are able to take these measurements, and they've been doing so for about a decade and a half. They've gathered over 1 billion pieces of data to basically make these very, very specific measures of what it looks like on the ground. And so that's how you end up with this really stunning visualization.
And as we all know, water covers a great portion of the Earth's surface, and there is a water ice melt component to this as well. Tell me about it.
Yeah, that's right. So, what they're able to do, so you have this cool visual, and that's great for us to be able to look at. But what scientists are looking at is not just what's, sort of this lumpy, bumpy Earth. They're looking at what's changing over time. And what they've been able to see is that the Antarctic and Greenland areas where climate change is heating things up and causing billions of tons of ice to disappear, as it melts, it changes the gravity in those locations. And so this map is actually, what's the data behind this map is what's able to help scientists understand what is going on in these remote and really fragile places where it's really hard to get instruments and to have observations full time on the ground. And so, yeah, what you're getting here is not just cool visual, it's cool visual and really important science behind it.
Brian, we love new words or words that are new to us on this show, and geoid is a new word to me. And this is described in your piece as a new geoid model. What does that mean?
So the geoid is the shape that we have here. It's just a fancy word to describe the lumpy shape that we see. When we look at the Earth from space, it's a nice, lovely sphere. When we look at the gravity field, it's a little bit different. And so geoid is basically describing the shape of the Earth, and actually the shape of the oceans if we didn't have these other forces spreading out the oceans across the Earth. This is what it would look like if they were all spread according to the forces of gravity around the world.
So if I'm a scientist who's interested in this imagery and I look at this, what are the kind of conclusions I might draw?
So there's the ice stuff that we talked about. And in addition, you can also look at other things like groundwater. So during the drought in California in the 2010s, there was so much groundwater pulled out of the ground that gravity actually changed there. They've also seen similar things happen in Australia and elsewhere. So we're able to both look at the poles in these really far off places and understand what's going on there. But we're also able to look at places that are maybe a little bit closer to home, but can be, benefit from having a bird's eye or a satellite's eye view of. And so there's a lot of ways that scientists are able to both look at this in terms of what is happening with the climate, what's happening with our natural resources, and also just understand the sort of shape of the Earth and what's going on, in the deposits whether it's iron, titanium, whatever, underneath the surface.
Wired's Brian Kahn. Perfect stuff. I really appreciate your time. Thank you.